Did you hear about oxygen and potassium? They went on a date. It was okay. Get it? Oxygen, potassium, okay. Hashtag let's make it awkward. All right. We are on the last sample for basic molar mass conversions. So we're up to number 10. And number 10 kind of applies some of the basic rules we learned from other things. Again, we're working with either a molecule or a formula unit of something. This guy here would be a formula unit because it's a metal and a nonmetal. This is a molecule. This one is I'll just put M for molecule, and this guy is a formula unit. Right, so we got that worked out. The other thing, we know that if we're going from grams to something, we need to know the total molecular weight or the total formula unit weight. In this case, formula unit would be 150.85. I got these numbers from the periodic table. Oxygen is 16, there's 4 of them, so 4 times 16 is 64. So we're going to use this number in our calculations, and that's actually grams per formula unit in this case, or grams per mole if we looked at it in another type of problem. So we start off by writing down what we know. And in this case, what we know is 285 grams of FePO4. We don't want grams, so that goes on the bottom. What we want to know is how many formula units we have. We cannot go directly from grams to formula units, just like we cannot go directly from grams to atoms, which is sample number 5. So if you're struggling with this one, go back and look at number 5 because it's very similar, except for we're looking at formula units or molecules, not individual atoms. So we need to go to moles of FePO4, and then we can cancel the moles and we can get the formula units, which is what we did in sample problem number 9. So formula units of FePO4. Now we just need to plug in a little bit of numbers. 1 mole. If you guys haven't noticed, I usually cancel these out for you. Sometimes I forget. But if you always use the consistent method of something, then you'll make less mistakes. And you also notice that you almost always have the number 1 with moles for these basic formulas. We know that the grams is 150.85. We got that number from over here. And we know that a formula unit is AN, which is Avogadro's number, 6.022 times 10 to the 23rd. When we plug all that in the calculator, I'll write it down here. 285 times Avogadro's number divided by 150.85 will give us a value of 1.14 times 10 to the 24th formula units of FePO4. So pretty simple by now, hopefully, because the later problems are set up by understanding the initial problems. Except for in 9 and 10, we're not talking about individual atoms. We're looking at molecules or formula units, which is just a slight change. If we look at B, the answer to B is 5.11 times 10 to the 19th molecules of CH5N. We know it's a molecule because it's all nonmetals. If we look at sample problem C, we have 6.91 times 10 to the 20th molecules of 2-methyl-1-propanol. And then D, the last one, is formula units because it's metals and nonmetals. 8.70 times 10 to the 17th formula units of mercury 2-acetate. So if you have any problems, come see me. I had a lot of fun doing videos 1 through 10. I'll continue to put videos up of different things, the next one being percent composition problems. But this is the basis for all that you're going to do in future chapters. When you do stoichiometry, when you do gas laws, when you do mole ratios, all the really fun stuff that you're really going to hate in chemistry, those of you that don't study, these are the videos you need to go back and watch. And if they don't work, then come see me so I can give you some one-on-one advice. That's all I got. Go out and do great things.